Hello again! How is it going? This is Fernando, welcome to my channel. Today I bring you a new exercise related to the topic of matrices. As you can see on the thermometer, we are already on orange level, but it means that there is still a long way to go before reaching the green level. Therefore, as always, first, open your notebook where you are doing your matrix exercises to add one more. Second, pause the video and try to solve it on your own. In the comments box, I will leave the minute where I'm presenting the solution so you can check if you got it right. And of course, if you don't know how to do it, please come with me because it will be a pleasure to help you in this exercise. Rock and roll!
Binnacle Project.
As always, let's read the problem together. It says, given the matrix X, and there you can see that it's a square matrix, A0, 0, 2, calculate the values of A for which the following expression holds true. X squared minus 3 times X plus 2 times the identity matrix equals 0. I must tell you that this 0 we just read is not the usual 0, but it's the null matrix of order 2, because the right side of the equation will give us an order 2 matrix. First, let's copy the matrix. X equals A, 0, 0, 2. And now, let's copy the expression we need to satisfy. X squared minus 3 times matrix X plus 2 times the identity matrix equals the order 2 null matrix. The first thing we have to consider is how to calculate X squared. We need to square this matrix, and I wish it would be as simple as squaring the 4 positions you can see there inside. I'm afraid it would be a very big mistake. Be careful with that. The correct way to calculate x squared is by applying the definition of exponentiation, that is, multiply the matrix by itself as many times as the exponent indicates, in this case 2 times. That's why we are multiplying matrix X by itself one more time, A0, 0, 2. This is the correct way. Once that's clarified, let's proceed with the multiplication. First, we locate the dimension of both matrices. Well, if the inner subscripts match, like in this case, it means that we can proceed with the product. Okay? Second, the outer scripts are telling us the dimension of the result. In this case, it will be a 2 by 2 matrix or an order 2 matrix, right? And now let's proceed with the product. Position 1, 1, row 1, column 1. That is, row 1 of the first matrix, column 1 of the second matrix. A times A squared. 0 times 0, 0. A squared. Second position, row 1 but column 2, that is, row 1 of the first matrix and column 2 of the second matrix. A times 0, 0, plus 0 times 2, 0, that is 0. Third position, row 2, column 1, row 2 of the first matrix, column 1 of the second matrix. 0 times A, 0, plus 2 times 0, 0. That is 0 again. Finally, position row 2, column 2, that is, row 2 of the first matrix and column 2 of the second matrix. 0 times 0, 0, plus 2 times 2, 4. So the result is this matrix. This is x squared, right?
Binnacle Project.
And now it's time to insert this result in the initial expression. X squared, that is A squared, 0, 0, 4. And we are also placing matrix X in its position, minus 3 times matrix X, A, 0, 0, 2, plus 2 times the identity matrix. Naturally, we will use the identity matrix of order 2. 1, 0, 0, 1. And as I told you previously, this is not the usual 0, but this is the null matrix of order 2, because you can see that all the problems is in order 2. We have 0, 0, 0, 0. Now we are going to operate and we will see the solution. Let's rewrite this matrix. A squared, 0, 0, 4, minus, and we're multiplying by 3 every element inside. That is 3 times A, 3A, 3 times 0, 0, 3 times 0, 0, and 3 times 2, 6. Plus, we are also multiplying by 2 every element inside. 2, 0, 0, 2. And we rewrite the null matrix 0, 0, 0, 0. Okay? Easy, right? And now, in only one step, we can operate all these matrices. How are we going to do it? Very easy. Let's consider the first position. A squared minus 3A plus 2. A squared minus 3A plus 2. The first position. Second position, 0 minus 0 plus 0. 0. Third position, 0 minus 0 plus 0. Also 0. The fourth position, 4 minus 6 is negative 2 plus 2, also 0. And you can see that we have combined the 3 matrices of the left side. Now we just rewrite the null matrix of the right side, 0, 0, 0, 0. And it's time to consider that if you want 2 matrices to be equal, we just need to equate the 4 positions. We're going to do A squared minus 3A plus 2 equals 0. Thanks God that the rest of the positions are the same. So let's go ahead. A squared minus 3A plus 2 equals 0. Just by solving this equation, we will have our problem finished. If you're allowed to use calculator, please go ahead. I will do it by hand. A equals minus B, that is 3, more or less the square root of B squared, that is 9, minus 4 times 1 times 2, right? Divided by 2 times A, that is 2 times 1, 2. 3, more or less 4 times 1 times 2 is 8. 9 minus 8 is 1, and the square root 1. Divided by 2, and there we have the solutions of this problem. Using the plus sign, 3 plus 1 is 4. 4 divided by 2, 2. Second, using 3 minus 1, 2. 2 divided by 2, 1. 2 and 1 are the values of the parameter A that satisfies this expression. That's it. I hope you've understood both the setup and the solution of the exercise well, but don't just rely on having seen me do it. I want you to be the one who reaches this result. It's the only way to be sure you are learning to work with matrices correctly. Let's do another problem so that the thermometer keeps rising. Rock and roll! And now, watch a theory video if you think you've gotten lost in some aspects, or skip to the next exercise to continue climbing. And as always, like, turn on notifications and comment. See you soon!